Welcome to APUA's Green Antigua PowerBlast, a search for future inventors and innovators right here in Antigua and Barbuda. I am Terry Andrew. Well, it's been 3 weeks of awesome competition and we've cut the field in half. We're now down to the final 3 teams. So far, the teams have built a solar cooker, an energy efficient home and a solar heater. And the projects will only get more and more challenging from here on in. We never said that it was going to be easy to become APUA's Green Antigua PowerBlast champion. Let's meet the remaining teams.
My name is Seth Joseph. My team name is The Physicists. And the 4 members of my team are Victoria Mansour, Kikilani Boswell, and Achieva Lotto, and Grace Somerville.
My name is Joshua Rubbis. I'm from the St. Mary's Secondary School. Name of the people that's on my team is you have John Williams, you have Kevin Joseph, you have Jaime Williams, you have Tennyson Cornelius.
My name is O'Neil Rowe and my team name is The Conquerors. The group members are Chevron Jones, Audie Daly, Shaquan Frederick, and Jason Blackwood.
Now you've met the teams. These are the folks who will be judging the competition. Marley Barnes, he's the energy officer at the energy desk. Ernest George, he's the plant manager at APC Maintenance and Operations Limited. And Ititus Simmons, he's the mechanical engineer in the environment division. Now, is your team ready for your next build? Yes. All right, this week you will be designing and building a wind turbine. For around 1500 years, man used wind to grind grains and pump water, and wind turbines are the evolution of that ancient technology. A wind turbine is a machine that turns the wind's kinetic energy into electricity. They come in a wide range of designs and sizes, with the largest one producing about 9 megawatts or enough power for almost 5,000 homes. Wind turbines make the most of a very abundant renewable resource, the wind. Who knew there was so much power in a nice cool breeze? Your team will have a total of 90 minutes to complete this project and must give an oral presentation to the judges while demonstrating your device. Your time will commence when you join your team at the Antigua and Barbuda Hospitality Training Institute. Good luck.
I feel good about the build this week. I think we did well and we constructed it well.
The way we approached our build was, as usual, brainstorming ideas of what we're going to do on the day of the build, practicing hard, very hard, so we know what we're going to do, how we're going to do it, so that we had everything done accurately and on time.
How we approached the build this week. We had an original design, but that wouldn't work. So I found another design that we were going to use, and then it was easier to build, so we chose that as our design.
Now here are a few things that the team should consider when building their wind turbine. A wind generator consists of three main parts. One, a rotor that catches the wind and spins a shaft. Two, a generator that will create electricity when its turbine is turned. And three, a solid structural support to hold it all together and keep it upright. Now they can go traditional or totally original as long as it works. The task will not be complete until their wind turbines can light a bulb just like this one.
Our approach to the build was just like, we just tried to get as much resources as possible.
Went about having 3-hour breaks, went to our teacher, and we'd go through the design over and over so that everything was in our minds, what we're going to do on the day today.
see, the construction of the project it wasn't so hard, but basically putting all the pieces together and make sure it sticks and it spins good, that was the main challenge.
Try to bring a bunch of things into consideration, like wind speeds and like altitude and stuff like that.
We use horizontal. We did them horizontally so that it does not matter. Well, it matters where the wind was coming from, but it doesn't matter how strong the wind is. The slightest amount of wind being pushed against it, it will move it, and that'll produce electrical energy. So we did a horizontal blade to ensure that we had electrical energy at all times.
Use cardboard for the blade because cardboard is a very light material. It's not that strong. That's why we reinforce it with the bamboo. But we use cardboard for the blades. And for the stand, it was a wooden stand, but we coated it with some towel wrap. And for the stand, it was a plastic stand, a sturdy plastic stand. So that was good.
I was in charge of I was in charge of building the turbine itself, the thing that spins, the blades that spin. Two of my teammates, Anna and Grace, were in charge of building the stand itself. And Victoria and Kiki were in charge of where the motor would be put and how it would be attached to the blades.
Myself and Jishon Blackwood, we did this stand around. We did a covering over the original stick that we were given. Siobhan Jones and Chapon Frederick, they did the blades itself. They carved the blades and ensured that everything was done accurately on the blades. And Audie Daly, he did some coverings for them, some circles, so accurately fit on the blades for support and for the backing of the wind turbine.
As we usually do, we split it up into parts. So like I took the parts of the blades and generally building the turbine. I was assisted by Tennis and Cornelius. Williams and Kevin Joseph and John Williams helped in the stand and how the anchor was going to hold it down and the wiring.
The design itself is very tall, the stand is very tall, the pole, so that you can get the high wind speeds to generate more electricity. It's very firm. It's not loose in any way. It's just.
some issues we have, the blade, how we adjusted the blade on the vane in terms of holding the blades to spin. We had issues when we had to stick it. It was not holding because how we designed the blade, as soon as you put it, the wind would just start pushing it. So we had issues with that, not being able to stay intact. Also,
in terms of tools, I wish we had a soda iron because the wires came in out and we had to plug them back in with hot glue, and then that was kind of, you know, a bad thing. And I also wish we had actually sturdy blades, good blades, and good wiring so we could connect it good so that it could spin the motor and it wouldn't have been so wobbly.
My biggest concern was like the wind speed, but thinking about it now, it wasn't really that much of a concern because if the wind speed would affect me, it would affect the other team too. But
one thing we would have wished for was a large turning wheel to ensure that more energy would be pushed down to ensure that the light would come on for the bulb because enough energy wasn't being produced.
The anchor was sturdy. right? But the tow roll came over the anchor. But if the wind blew too hard, it would shift the axis, and then that would create a blockage between the wind and the blades. So that could have been improved more.
We finished so fast because it was just a simple build, and we knew what we were going to do, but some of it we did wing it. We didn't improvise, but we knew what we were going to do through most of it, and it was, as I said, it was a simple build. To be honest with you, I'm not really that worried for us finishing so quickly. I'm good.
Well, we maximized on our time. We used our time. Everything was done in time. Everything was done in time. Everyone knew what they were supposed to do. So we went forward and we went through everything on time because we each knew what we had to do. So we didn't have issues with time.
As every week, again, we finish first, and then we were always trying to just look at all the mistakes and the tweaks. If you look at our design, it's quite wobbly, but you know that was a back set we didn't notice before. But if we had, say, another 10-20 minutes, we could have fixed it. But the time, it was well spent.
Good afternoon, judges. The SAS physicists present a wind turbine. Our design is a vertical axis wind turbine. We chose this design because it does not need to track the wind, the direction of the wind. As the wind hits the surface of the blades, the rotational momentum is created that causes the blade to turn, continuously turn. As the blades turn, the attached motor spins, generating electricity. The faster it spins, the greater the output voltage. A limitation in our design is the distance between the blades. If the blades are far apart, it creates a rotational inertia that decreases the speed of the blades. An improvement that we could have made would be to overlap the blades a bit more. And as you can see, it is very tall so that it gets a lot of altitude, and the wind speeds, as you get higher, the wind speeds pick up. So you get more electricity being generated from this project.
Today we built a wind turbine with horizontal axis, which converts kinetic energy into electrical energy. This design was chosen since the blades will always move perpendicular to the wind, so that the blades will rotate at the same time and maximum energy is taken from the wind. The tall tower allows the blades to face high-speed winds at a high altitude, which means more energy. Wind turbines provide clean energy since it does not produce any waste product and emits very low levels of greenhouse gases. As you can see with our wind turbine, we have our adjuster on the back of it, so we could adjust it depending on the direction of the wind. We're always able to just turn it and adjust it so that we have maximum energy being produced in the wind turbine. The blades, you can see that how we design the blades so that the wind, no matter how strong the wind is or how weak it is, it will always be spinning. As you can see now, it's yes.
My team design for the wind turbine is a very energy efficient and easy project to build. A wind turbine is basically a machine that converts the kinetic energy in the wind into electrical energy. Our design here had three main components or three main parts. You have the turbine, the stand and the anchor. The most important part of the project is going to be the turbine. The turbine is basically used to convert the wind energy into electrical energy. The turbine has two main parts, that's going to be the blades and the motor. The function of the blades is to harness the kinetic energy from the wind and create a rotation. This rotation will then spin the motor, causing friction and then electrical energy. The stand is to hold up the project and can be a pathway for the wires, and the anchor is just to basically hold up the project and make sure it doesn't fall over. Our design is very cost efficient, a renewable energy source, and thus saving money, power and energy.
Now for that moment we all have been waiting for. The judge's decision. The results are in. For our first team, the judges thought that their design was well constructed. It was very durable. And it was accurate. It ran very smoothly and produced volts 1.4 volts. That team, Irene B. Williams, you're safe this week. We'll take a short commercial break. The bottom two teams this week when we come back. Welcome back. Now for the bottom two teams this week. St. Mary's Secondary and St. Anthony's Secondary. Step forward, please. Of the two bottom teams this week, the judges thought that one of your designs was very unique. It was neat and it actually looked doable. However, the downfall was that it was less efficient in producing power, only producing 0.3 volts. The other design, the judges thought that the three blades were more efficient than the vertical axis design, which is the horizontal axis. The three blades were more efficient. Although it was unstable, the blades was very heavy and the shaking made it less productive, even if it produced 0.7 volts. Gentlemen, one of you teams must be going home today. As we approach our final week of the APUA's Green Antigua PowerBlast. St. Mary's Secondary, you're safe. St. Anthony's Secondary, you do not have the power. Join us next week for the final competition.
I would like to thank the APUA members for putting this competition together. I would like to thank my teacher, my teammates for trying their best and everything and working together. And I learned a lot of things. I learned from this project the heat transfer and all, and the different ways you can transfer heat. And next year we'll try our best to come back and do better.